Okie dokie artichoke. So, section 10.5 has to do with the Pythagorean theorem. This is this theorem that relates the lengths of a right triangle. A right triangle is one in which one of the angles is at 90 degrees. Remember that all the angles add up to 180. This angle 90 plus those two angles must add up to 180, but in a right triangle, one of the angles is always 90. And the side that is opposite the right triangle, this is the symbol for a right triangle. You just put a little square here. The length that is opposite the right triangle is called the hypotenuse. So this is the hypotenuse. I don't want to misspell it. Okay, noose. There's the hypotenuse. So C represents the hypotenuse. That's the longest side of the right triangle. It's always opposite the 90-degree square part here, the 90-degree part. Okay, and these are referred to as the legs of the L-E-G-S, legs of the right triangle. All right. And what Pythagoras actually figured out, he's a real guy, Pythagorean theorem. Pythagoras, from ancient Greek, if I remember correctly, he figured out that if you take the value of the hypotenuse squared, it equals the sum of the squares of the legs. All right? So C squared equals A squared plus B squared. That is very useful. Let's say that we have a right triangle where A is equal to 10 and B is equal to 15. Ooh, there goes the bell again. Just check something. Therefore, let's find the value of the hypotenuse. So C squared equals 10 squared plus 15 squared. Well, 10 squared is 100. 15 squared is 225. And so C squared is going to equal 325, right? 100 plus 225 is 325. That's the value of C squared. So the value of C equals plus or minus the square root of 325, which is, let's go ahead and do that on a calculator. Square root of 3, Chihuahua. The square root of, God, I did it again. Square root of 325, which is plus or minus 18 or so. If they ask you to round, this is 18.03. But hold the phone, Wilbur. There's no such thing as a negative length of a triangle. So the actual missing length in this case is not the missing link. That's a joke. The missing length, C, would be equal to 18.03. Again, there'd be no negative answer. A negative answer just doesn't make sense. You could solve for the hypotenuse. You might be asked to solve for one of the legs. Let's just do a quick other example. So let's say that, I don't know. Let's say that C is equal to what? 100, and B is equal to 75. Then what's the value of A? So 100 squared equals A squared plus 75 squared. Let's solve this for a squared. So a squared equals 100 squared minus 75 squared, where I subtracted 75 squared to the other side. By the way, you could have done the squared first if you preferred, just in terms of, 100 squared is what, a 10,000? And 75 squared is, oh, who the heck knows? 75 squared is 5,625. I'm just plugging away on my calculator. So that's 4,375. But you're not done. That's a squared. And so to find a, it's going to be equal to plus or minus the square root of 4,375. But remember, there are no negative lengths. So it's going to be the positive answer, which is 66.14. Okay, that's how you can find one of the values of the legs. There is a special case here, which is always nice to know. If you have a equal to 3 and b equal to 4, what's the value of c? Again, this is a special case. 3 squared plus 4 squared, that's 9 plus 16 equals 25. And so c equals 5, which is c equals the square root of 25, which equals 5. We refer to this as a 3, 4, 5 triangle. A 3, 4, 5 triangle is very handy. It's whenever the two legs are 3 and 4 respectively, hypotenuse is going to be 5. The last thing in this is called the converse. And that's just for proving whether or not, if you're given the lengths of a triangle, whether or not it's a right triangle. So if the 3 lengths of a triangle, when you square each leg and sum them up, if they equal the square of the hypotenuse, the longest leg, then it's a right triangle. If they don't, it's not a right triangle. It doesn't mean it's not a triangle, it's just not a right triangle. So it's called the converse, all right? And the converse is just used to prove whether or not lengths represent a right triangle. So here's an example out of the book where we have 9, 12, and 16. So remember that C has to be the longest leg. So we'll make that A, B, and C. And what we're going to do is determine, or just check whether 9 squared plus 12 squared is equal to 16 squared. If it is, it's a right triangle. If it's not a right triangle. So 9 squared plus 12 squared, does it equal 16 squared? And I find it interesting how they write this in the textbook. They put a little question mark over the equal sign because they don't know whether it is or not. So 9 squared, of course, is 81. 12 squared is 144. And 16 squared is, well, that's too much for my brain at the moment, is 256. I should have known that. Well, what is 81 plus 144? 81 plus 144 is 225. That does not equal 256. So this is not a right triangle. Again, it's a triangle, but it's not a right triangle. if this had come out to be 256 and that was 256, then yes, it is a right triangle. So the answer to this one is no. It's not a right triangle. No, 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 no. So I think that's all the important stuff in section, in section 10-5. All right. Okie doke.